All right, so we're going to be talking about the sum and difference identities in this section. Quick little warm up. Feel free to pause the video here and try this identity problem with a little review from 4.1. I'm going to go ahead and go through it right now. All right, so in this one, we have a couple options here. The left-hand side looks a little bit more simple, or sorry, a little bit more complicated here. So that's the one that I kind of want to work with. Few different options to us. I could combine these together. I could combine tangent t plus or minus cotangent t, kind of see what happens there, and then divide through the sine and cosine. I could divide through sine and cosine first, and then combine things together. I kind of have my options. First thing I'm going to do is rewrite the numerator in terms of sine and cosine. So I have sine t over cosine t minus cosine t over sine t. And that's all divided by sine t cosine t. So again, options here, I could divide this through to each term, multiply by the reciprocal of it, I suppose I mean. I could go ahead and combine these together, see what happens with that. Yeah, but both methods seem valid at this point. So I'm going to go ahead and divide this through, or the other way to think about it would be to multiply the top and the bottom by the reciprocal of this. So multiply it here, gets rid of that. Multiply the top by this thing, same thing. You got to make sure to distribute this. So I'm going to go ahead and do that, see what happens with it. So we end up with multiplying it in this first part. We're going to get just sine t in the numerator. And then in the denominator, we're going to have also sine t, and then cosine times cosine will give us cosine squared. So that's that first one. And then my second multiplication here, again, still going to just get cosine t in the numerator. In the denominator, I'm going to end up with sine squared because of these, and then a cosine. So I'm going to write the cosine first just for simplifying purposes. Sine squared. A little bit of simplifying here. Cancel that out. Cancel that out. So that we end up with 1 over cosine squared t minus 1 over sine squared t. It's important here to keep in mind where you're trying to get to. Trying to get secant squared minus cosecant squared. We're sort of there. We kind of have it. 1 over cosine squared is the same thing as secant squared. So using our reciprocal identity. And then 1 over sine squared is cosecant squared. Again, using our reciprocal identity. So in that way, we were able to verify it. So this is one way. I think the other option would be to just focus on this numerator, put those together, see what we end up with, and then kind of end up doing what we did. This one worked out nicely, though. I think this was probably maybe the faster way to go. All right, let's go ahead and clear this off and start talking about the sum and difference identities. So sometimes it's nice or necessary to split up an angle into a sum or difference of two angles. So for example, if we're working with the angle of 75 degrees, sometimes it's nice to think about it in terms of 30 plus 45. Why would we want to do that? Well, these are on the unit circle. 75 is not. It's kind of it. So that we can kind of use the unit circle to help us, essentially. That's not the only way to get 75. Using unit circle angles, we could also do something like, I guess, what would that be? 120 minus 45. We could do it as a difference as well. That would also give us 75. Anyway, we have a couple identities that help us work with something like this. So here are the identities for sum and difference formulas for sine, cosine, and tangent. We are mostly just going to be looking at these sine and cosine sum and difference formulas. So sum when it's plus, difference when it's minus. And we had that problem where we were doing 30 plus 45, right, to get a 75-degree angle. And we could have went ahead and used this formula right here to evaluate it and get an exact value, but we're going to go ahead and practice that in a few minutes. Now, I'm not really going to have us work with these tangent formulas. You can use these to evaluate tangent as well, or you could use these tangent formulas. These are the ones you want to know, sine and cosine, or at least how to find them. All right, so let's go ahead and do that problem number 4. So we're going to find the exact value of sine of 75 using this particular split up, so 30 plus 45. So we're going to use a sine sum formula because we're adding two angles inside of a sine function. And this is the sine formula. So we're going to go ahead and rewrite this. Sine of 30 degrees plus 45 degrees. So for our problem, this is the A and this is the B. So we have sine of A, sine of 30 degrees, times cosine of B, cosine of 45 degrees, plus cosine of A, which is cosine of 30 degrees, times sine of 45. Now, at this point, we need to consult our unit circle to figure out all of these different values. So if you want to take a peek at that, you can find them. I'm going to go ahead and just write them out. So this one is 1/2. This is square root of 2 over 2. This is square root of 3 over 2. And this is square root of 2 over 2. You're going to see a lot of these same values show up, positives, negatives, but a lot of times when we're using these sum and difference formulas for angles like 75 degrees, a lot of the same stuff shows up. I mean, these are basically just all the numbers that are on the unit circle anyway. Okay, so let's go ahead and multiply that out. So 1 times root 2. And then square root of 3 times square root of 2. Common denominator already. A lot of times you'll see this written as a singular fraction. So you'll see it written as square root of 2 plus square root of 6 over 4. Those numbers on the top could switch around, right? We could commute addition if we want to. Square root of 2, 6 plus square root of 2. Same idea here. All different representations of 75 degrees should simplify to something that's equivalent to this. This is the exact value of the sine of 75 degrees. And this is really the only way to find it. 75 is not on the unit circle. We got to use this sum formula. Okay. Let's try another one. Let's try one that is actually a difference formula, not distance. So we're going to try to figure out what cosine of 105 degrees is. And the way we're going to split that up is we're actually going to split it up as 150 minus 45. That's equivalent to 105. Since we're doing that as a difference, subtraction, we're going to use the cosine difference formula. So we're doing cosine of 150 minus 45 degrees. Okay, so our A is 150, our B is 45. Cosine A, cosine B. So it's going to be cosine of 150 times cosine of 45. And added together with that, sine A, sine B. So sine of 150 times sine of 45. Again, this just becomes a situation where we need to consult our unit circle to find these particular values. I'm going to go ahead and write them out here. So sine of 150 is negative square root 3, or sorry, cosine of 150 is negative square root 3 over 2. Cosine of 45 is the square root of 2 over 2. Sine of 150 is a positive 1/2, and sine of 45 is square root of 2 over 2. So again, you'll notice the same values are kind of showing up as we just had in the previous problem. Multiply these out here, we get negative square root 6 over 4. And then over here, we end up getting square root of 2 over 4. Almost identical to what we had before. We have a negative involved, so that's a little different. A lot of times you'll see this answer combined into a singular fraction, and maybe even the order moved or maneuvered around. You might see it written out like this. This is an equivalent form of this. That's just shifting the order and putting it together into a fraction. And again, this is the exact value of the cosine of 105. And this is the only way to find that using this sum or difference formula. All right, let's go ahead and clear this off. And let's just kind of practice here. Let's do 2 more. These are going to be done, slightly differently here, but we'll take a look at them. So we have sine sum and sine difference, our cosine sum and cosine difference formulas. And we have cosine of 15 degrees. So we want to rewrite that as cosine of 2 angles, either added or subtracted. In this case, I think subtracted is the way to go. You could go about it a few different ways. I think one of the more straightforward is just a simple subtraction of 60 minus 45. That would be equivalent to 15 degrees. You're going to notice that one of your angles should be a multiple of 30. So some multiple of 30 degrees, and then 45 degrees. You can almost always write it that way. One of them is going to be 45, or a multiple of 45, and a multiple of 30. I like to just always use 45 and then just make the other number be a multiple of 30 so that it works out for it. Pretty much always works. All right. So here we go. We have that one. That's a cosine difference formula. So to simplify that one, we're going to use this formula right here. We just used that on a previous one, so it should be pretty straightforward. It's going to be cosine of 60 times cosine of 45 plus sine of 60 times sine of 45. Pretty straightforward. All these angles are in quadrant 1, so everything here is going to be positive. So we end up with 1/2 root 2 over 2 and square root 3 over 2, square root 2 over 2. Again, notice how similar this is to ones that we've already seen. Multiply this out, square root of 2 over 4, square root of 6 over 4. We basically already saw this exact answer in slightly different forms here, a little bit of different negatives and stuff, but final answer here, when we combine it into a singular fraction, looks something like this. Not too hard with relatively simple angles like this. All right, I'm going to go ahead and clear that and work on the next one. The next one here is a little bit weirder. We're going to have to apply some other properties here really quick first. So first of all, sine is an odd function. So I'm going to rewrite this as negative sine of 195. That way I don't have to worry about this negative angle at all. I think that's the easiest way to deal with that. Now I just need to break down 195. And so from what I was saying before, let's just start with 45. 45 plus what? Well, 45 plus 150. That gives us a nice straightforward calculation with that. Those are both unit circle angles, and now we can just evaluate this. So we're using the sum, right? We're adding, and we're using the sine sum formula up here. And the only thing that's going to be slightly different is we do have this extra negative on the end of it. So when we do apply that, we're going to stick a negative around the outside just to apply that negative to my final answer. And it's going to be sine A cosine B. So sine 45 times cosine 150 plus cosine 45 times sine 150. And there we go. Now we just use our unit circle, find those numbers, kind of simplify things down. Still got this negative on the outside, sine 45, root 2 over 2. Cosine 150, that's negative square root 3 over 2. Cosine 45, root 2 over 2, sine 150 is a half. Again, just getting these from the unit circle. I have them one over here that I'm looking at, so let's go to multiply that out. We'll apply the negative sort of at the end. We end up with negative root 6 over 4 plus root 2 over 4. Let's go ahead and stick that into a singular fraction. Negative root 6 plus root 2 over 4. And then we stick this negative in there. We had to distribute to the numerator. Final answer, negative times negative, that root 6 turns to a positive. This becomes a minus. And there we go. That would be our final answer for that. Again, I'm sticking this negative here. Negative times a negative turns this to positive. Negative times positive turns that to a negative. There we go. That's what we end up with. Not too bad. You need to know how to do this. Okay. So we can also use these identities when we're verifying identities. So if we happen to have some trig functions where we're adding angles together involved in our identities, or subtracting angles from each other when we're involved in our identities, we can use these two formulas. Well, the sine sum, sine difference, cosine sum, cosine difference, or even tangent to sort of help us out. So let's go ahead and take a look at this one. We have our sine sum. We can expand that out. Again, I got the little formula down here at the bottom. This expands out into sine alpha cosine beta plus cosine alpha sine beta. And now we're adding it to this other thing. This is our sine difference, so we're going to expand that out. That's sine alpha cosine beta minus cosine alpha sine beta. At this point, we want to make sure we identify some like terms. So we have sine alpha cosine beta, sine alpha cosine beta. They're both positive. We add those two things together. We end up with 2 sine alpha cosine beta. But we also have some like terms here. Cosine alpha sine beta, positive. Cosine alpha sine beta, negative. Those things cancel each other out. And there we go. We end up with exactly what we were trying to demonstrate in the identity. Again, it's an identity, so we're working with one side, trying to show that it matches the other one. Pretty easy identity in the scheme of what we've been doing in the past. Okay. Let's go ahead and do one more of these, just kind of see how it goes. We do need to be careful. Remember, make sure, to pay attention to the argument of the trig functions, because if alpha's on the inside, you can only put that together with other alphas and so forth. So again, up here on top, we can expand this a little bit, see what happens with it. So we're going to take this and expand it using my sine difference formula down here. We have sine alpha cosine beta minus cosine alpha sine beta. And all of this is being divided by cosine alpha cosine beta. So I'm going to go ahead and distribute this division. So I'm going to divide both parts over here with this. So we end up with sine alpha cosine beta on top, and then cosine alpha cosine beta on the bottom here, minus, and then we have cosine alpha sine beta on top, divided by cosine alpha cosine beta. We should be able to cancel some things out. But again, remember, we should only be kind of working with things that have the same argument inside there. So notice we have a cosine alpha, or cosine beta, and a cosine beta on the top and the bottom. Those can cancel. So now we have sine alpha divided by cosine beta. Nope, cosine alpha, same trig function. So we can put those together using our quotient identities, but we'll do that in a minute. Over here, we have cosine alpha, those can cancel. And we end up with sine beta over cosine beta. Again, same argument here, so we can use our quotient identities. So we have sine alpha over cosine alpha turns into tangent alpha, and sine beta over cosine beta turns into tangent beta. And that's what we were trying to get to. I was keeping that in mind, as I'm going, knowing how I'm trying to get there. Sometimes you may even want to kind of rewrite this just to kind of get an idea of like what that might look like along the way as we're trying to get to it. So you might have wrote this in terms of sine and cosine and been like, okay, I'm trying to get here, and then you get here and you notice it, right? Keep that in mind. Keep in mind where you're getting to. All right. Homework, make sure to do as many of the 4.1 identities worksheet as you can. If you want to, there are some extra problems down here that could help you out. Not going to do them right now, but you could pause the video and try some of these. Anyway, see you guys later.